Hey guys, this is Coach Brian with part 2 of your final exam review for spring 2025. So this should be the second page of your review, and we'll start with number 6. So number 6 says that these two triangles are similar. When you see similar, you should think that they are proportional. All right, they are proportional. And it says the area of the larger triangle is 185 square feet. So that's our larger triangle here. We're going to say area equals 185 feet squared. And so what we want to find out is the area of the smaller triangle. And when we talked about this at the end of Unit 11, we said that if you can find the proportion or the ratio of the sides, you can square those numbers to find your proportion of your area. So these two triangles have sides that are 30 and 25, and I can set those up in a 30 to 25 ratio. And then what you would want to see is there a GCF? Can these be reduced? 30 to 25, both numbers, can be divided by 5. That's the biggest number they can both be divided by. 30 divided by 5 is 6, and 25 divided by 5 is 5. So these actually, for their sides, have a 6:5 ratio. Now, during this lesson, we said that when you're trying to find area, you would actually take these two numbers and square them to find the ratio of your areas. So 6 squared would give me 36, and 5 squared would give me 25. So their areas are 36 to 25. Now, how does that help us? Well, the larger triangle has an area of 185, and the smaller one has an area we don't know. So we can set these up as a proportion, and we can say 36 is to 185 as 25 is to our unknown. Then we can cross multiply. And when we do that, we get 185 times 25, 4,625, and 36x. So what would we do next? Divide both sides by 36, and we get x, which is the area of our smaller triangle is 128.5 feet squared. All right. Let's move to number 7. Number 7 says Angel's Food Incorporated has a soup can in the shape of a cylinder with a radius of 2 inches and a volume of 50.3 cubic inches. The company wants to make a larger can with the same height. So their height is actually going to stay the same. We don't know it, but it's going to stay the same. And they're going to take the radius of 2, and they're going to triple it. So 2 times 3, the new radius is going to be 6. It says, what will be the effect on the can's volume? So what we want to do here is figure out the height first. We want to figure out this missing height, okay? So what we're going to do is we're going to write out our volume formula for a cylinder, which is pi r squared h. And then we're going to plug in the numbers we know. We know the volume is 50.3. We know pi is pi. We know the radius is 2, and h is unknown. And so on this side, we can simplify this by multiplying everything out, and we get 4 pi h. On this side, we still have our 50.3. And so we're trying to isolate h because we want to know the height. So we divide by 4 pi. Divide by 4 pi. And when you divide 50.3 by 4 pi, you get about 4. H is approximately 4. So we're going to use 4 as our height. Now, what we want to see is how the original volume of 50.3 compares to our new volume. So our new volume is going to be pi times 6 squared times 4. The reason we're using 6 squared now is because we tripled our radius. And when we multiply this out, 6 squared is 36. 36 times 4 is 144. And then times pi is pi. 144 pi. Now, if you type that fully into your calculator, 144 pi, you get that the volume is 452.4. And so what we're trying to figure out is we tripled our radius, okay? Our radius went from 2 to 6, and our our volume went from 50.3 to 452.4. So we're trying to see if there is a scale factor or a number in there, like if we tripled it, did it go up 3 times? Did it go up 6 times? Was it cut in half or a third? So we're trying to figure out what that is. So when you're trying to figure out a scale factor, okay, you can take a figure from your bigger shape and divide it by your smaller shape. And when you divide 452.4 by 50.3, you get 9. That means it is 9 times bigger. So the way we would conclude that is we would say triple radius equals 9 times volume. So we tripled it, and our volume went up by 9, like a factor of 9. All right, a can had a diameter of 4 inches, so all the way across this can is 4 inches, and a height of 1.5 inches. What is the area of the label? What is the area of the label? So what we're trying to figure out here is the lateral surface area. Lateral surface area. Because we're ignoring the top and the bottom of the can. We're only trying to figure out the label, which wraps around it. And so the lateral surface area of a cylinder is 2 pi r h. 2 times pi times r times h. So half of our diameter, okay, if the diameter is 4, half of that is our radius. So our radius is 2. And we can plug in 2 times pi times 2, because that's our radius, times 1.5, because that's our height. So when we multiply this out, we get, 4 times 1.5. I guess I could just go ahead and multiply that also. Oh, that's a huge eraser. We get 2 times 2 times 1.5, which is 6. Multiplied by pi is pi. So our lateral surface area is 6 pi. And that is an area, so it's in inches squared. Now the next question is, what is the area of the metal? So that wants to know the whole can. And when we're looking for our total surface area for a cylinder, the formula is 2 pi r h plus 2 big B, which is pi r squared for a circle. So again, seems like a lot of information, but we already have all the numbers we need. The radius is 2, radius is 2, height is 1.5, and we actually already, when we did our math over here, we already got this portion of the equation done. So it's going to be 6 pi, and then we're going to be adding whatever this second half is. Well, 2 squared is 4. All right, that's 4. And then 4 times 2 is 8 times pi is pi. So when I work all this out, I get 6 pi and 8 pi. And since they both have pi, that makes them like terms, and it is 14 pi inches squared. All right. Volume of a cone. Volume of a cone is 18 pi. Radius is 3. What is the height? So when you have a cone, okay, it has a circular base, and then it comes up to a peak, okay? Comes up to a peak. And our height is going to be, if we were at the peak of this cone and we dropped something straight down into the center of it, that is our height. All right, another word for it is altitude. So we're looking for the altitude. So what we need to do is on our formula sheet, go to cone and find our volume formula, which is 1/3 pi r squared h. Pi times r squared times h. Well, they do give us all these numbers. The radius is 3. The height is unknown. The volume is 18 pi. And so what we want to do is we want to isolate this h, which means we need to get the 1/3, the pi, and the 3 squared all to the other side. Let's go ahead and simplify what we can on the right side. We can square 3, which is 9, and we can multiply it by 1/3, which is 3. So just to clean up what we have 18 pi equals 3 pi h. We're still trying to figure out h, so we want to get this 3 pi and move it to the other side using division. So when you divide a pi by a pi, they cancel out, and 18 over 3 is 6. So our height is 6 feet. The end. All right, last one for part 2. Emmy is wrapping a dollhouse. Wrapping's the key word right there because it lets us know we're dealing with surface area. And it's in the shape of a cube with sides of 12 inches and a triangular pyramid with a slant height of 10 inches. She wraps it perfectly. How much wrapper is she using? So I am going to go ahead and correct this part. This is not a triangular pyramid. It's on top of a cube, which means it's got a base that is a square. So we're just going to call it a square pyramid. So the information they give us is that the height from the top of the pyramid down to the center of it, okay, down to the center of it is 10, okay? They also tell us that all of the edges on this cube, so the height, the length, and the width, all equal 12. So what we have is a composite shape here. If you think about it, the part I'm about to shade, let me get a lighter color. There we go. The part that I'm shading right here, that's not what I wanted. Let's just switch tools. I'm going to switch over to the crayon. That'll work. All right. The part that I'm shading right here with the crayon is not going to be wrapped, okay? It's not going to be wrapped. So that means for the pyramid part, we need to find the lateral surface area because we're wrapping the sides and not the base. So the lateral surface area of a pyramid is 1/2 perimeter of the base times L, which is slant height. Then for the cube, all right, follow with me here. We're wrapping 1, 2, 3, 4 sides in the bottom. So we're wrapping 5 sides of the cube. So what I want to show you is, if you look at the total surface area for a cube, the equation is 6 times s squared because you're wrapping 1, 2, 3, 4, 5, 6 sides. But for this one, we're not wrapping the top. So let's take this 5 or this 6 and make it a 5 because we're wrapping 5 sides of the cube. So we need the surface area of the pyramid and we need 5 sides of the cube. So let's go ahead and plug in what we know. First of all, we're going to be adding these two things together. So let's write out the entire equation. 1/2 times P times L, okay? I'm going to put that in parentheses because that's part 1, plus 5 times s squared. Now, let's substitute what we know. The perimeter of the base of the pyramid. The base of it is the square where all the sides are 12. So your perimeter is going to be 4 times 12, which is 48. Our L, all right, this cursive L is our slant length, which they tell us in the problem that our slant height is 10 inches. So we're going to do that little bit, 1/2 times 48 times 10, and we're going to add 5 times the side squared. And if you look, the sides of this square are all 12. So it's going to be 5 times 12 squared. So now we need to do what's in parentheses. So 48 times 10 is 480. Divided by 2 is 240. Then we're going to add 5 times 144. 5 times 144. And that will give us 720. And then we're adding these two things together. So 240 plus 720 is 960. And it's surface area, so it's going to be inches squared because it's an area, not a volume. So just to recap what we did right there, we found the lateral surface area of the pyramid because we did not need the base of it, we just needed the sides. And then we found the total surface area of the cube minus one side because we're not wrapping the top of it. And that is